Hi guys, and welcome back. We are continuing with this long question, which is quite tedious, that requires us to just prove uh, all the way. And so we have done 11.1, we have done 11.2. Now, because we have done that and we have proven that without any doubt, we can actually use this information, okay? And we will just refer to it to say proved, or say proved above, as you are writing in that paper. So in 11.3, they say prove that ET bisects BTC. Now, I've written what we know already here, okay? And you will remember that as we were proving that TBEC is cyclic, we actually proved that T3 is equal to T2. So we're just going to write this conclusion here that by 11.2 above, okay, so assuming that the examiner sees that, obviously, we established that T3 is T2. Thus, okay, ET bisects BTC. Okay, perhaps the nice word to use here is not by. We can just say from, or we can say in 11.2 above, it was proven that, whichever way you want to express yourself. Remember, I said geometry is a language. You are expressing yourself, to the reader. You are conveying a message that you are to a reader. You are telling them, interpreting to them what you see. So the important thing here is using a clear symbols, clear grammar, so that any reader is able to understand what you're telling them. So this one, that's why it's even 2 marks. Really, there isn't much to do here. We want to look at this. It is given that if it is given that TB is a tangent, this thing here is a tangent to the circle through BFE. I've done that already to save time. Prove that TB is equal to TC. In this case, guys, we actually have to show that so let's write the required to prove statement. We are required to prove that TB is equal to TC. Now, our aim when we are required to prove such is to show that actually the base angles or the angle opposite this equal sides are actually equal, all right? So we must just show that B2 is C2. Now, guys, as I said, we have information. We have added more information by answering the previous question. So we have more information at our disposal. To start afresh and all that, we don't want to waste time, okay? So I'm going to use what we have already. As a matter of fact, I'm going to start here with this thing that they are telling me. If you imagine TB as a tangent, you can see clearly that BF is a chord. And if BF is a chord, then this angle here, angle B2, should actually be equal to E2. So they were not just giving you that information for nothing, but it's because you're going to need it. So we can start actually by using that and conclude that B2 is equal to E2, and our reason is tan chord. Okay, and then having said that, guys, we are going to look at triangle. So you can tell the reader, consider triangle BTE. Okay, that's what you can tell them. What is happening there? Sum of angles in a triangle. We can see that B1 plus B2, I must indicate that, plus T3 plus E2. This is all 180 degrees. Okay. But well, from this, we can perhaps try and solve a bit and really see what we can come with. Okay. We have established now that actually E3 is what? E3, sorry, not E3, E2 is B2. So what I'm gonna do, I'm gonna write here, okay, there's B1, there's B2. By the way, what is T3? From the previous question, we established that T3 is B1. So I'm going to substitute. Let me write this in a different color so that you can see that I've done some substitution based on what we have proven before. And then this was in 1, okay? And then what is E2? We just established now that E2 is B2. So, and then I will go back to my black, and then this is 180. So if they want reason, you can say by 11.1, question 11.1. Okay, good. Now we can see here there are some like terms. So we have that 2b1 plus 2b2 is 180 degrees. And this leaves us with the conclusion that b1 plus b2 are 90 degrees. So actually that angle there is a right angle. Okay, now we are not done. We are not done. We are almost there. We have just proven in the previous question that this thing is cyclic. And remember, the aim is to show that C2 is B2. So these angles really do relate using the fact that this thing is cyclic. So I'm going to write somewhere here, continue here, and say, well, B1 plus B2. Okay, that does not look like a B anymore. All right, so yes. So B1 plus B2 plus what? C2 and what? C3 should give us what? 180. Why? TBEC is cyclic. Or you can say opposite angles of a cyclic quad are supplementary. Okay, so what do we know? We know that this thing here is 90 degrees. So let me maybe call this star or 1, whatever. But so now I'm going to say, well, so 90 plus C2 plus C3 is 180 by star. Okay, so what does this mean? It means that C2, okay, plus C3 is 90, okay? But guys, C3 is just B1, okay? So therefore, C2 plus, okay, B1 is equal to 90 degrees, okay? Why? Angles opposite equal sides. We know the two tangents are equal, right? So therefore, this angle B1 is actually 90 minus C2. Let's call this star 1. Right? Now, we can see we are actually almost there. So we're going to just play around with this. Guess what? If I substitute this thing in that thing, I have actually arrived at my aim. Okay, and so I can conclude. So I'm going to do that just in the middle of the screen here. You can see now. So I'm going to say here, substitute star 1 in star. So I'm just playing around here. So then I'm going to have the fact that, well, B, so remember what does star say? B1 plus B2 is what? 90. Okay, so if I substitute B1 is 90 minus C2 plus B2, okay? And this is 90. But you can see this 90 will take care of that 90, and so B2 is C2 as required. And there, guys, I have proven actually that this line, okay, this line TB is equal to line TCY because the angles that are opposite these sides are equal, okay? Remember, it's basically the converse of isosceles triangle. You know isosceles triangle, if you've got two sides equal, then you can conclude that the angles opposite those sides are equal. Or if you've got the angles that are equal, then you can conclude that those sides are also equal. And that's how easy it is. Hence, prove that T is the center of the circle through A, B, and C. So let me quickly clear up my screen here so that I do not become a nuisance to you. So I will pause the video here, clear up, and then in the next video, we wrap up with basically the simplest question. All right, cheers. So guys, we are now going to wrap up with 11.5. You can see I've cleared up and I've just shown here now what we know. We now have three things or facts now which we have proven. So we want to prove, hence prove that T, we must prove that this point is a center. It looked like a center, yes, but we could not use the fact that it's a center because we had not proven that, guys, okay? So, what we need to prove is that it is the center of the circle through A, B, C. To prove that, guys, so we are required, our required to prove statement in 11.5 is that T is the center. Okay, so what do we know about the center? If it is the center, then or any line from the center to the circumference, whatever direction it takes, those lines should be equal. So my aim is to show that TB is to show that AT rather, or TA if you like, let's say TA is equal to TB, which is equal to TC. Now, this we have proven in the previous question. So I just need to show that this thing is either TB or TC. At this point, there's quite different ways to do that, but actually the simplest way is to show that C1 and A1 again are equal. It has been the simplest strategy, and I believe this is what you also now have come to be more associated or acquainted with. So let's go with it without any further ado. So I see here that angle T2 is actually angle C1, and this is because these are alternating angles, and the lines that are parallel is EC, AC, and TE. Okay, you can see that Z, so that is why we say that. Now, the next thing really, because it is all nice and easy at this point, is to state what I have already used previously or proved previously. We know that T2 is T3, and this was done, you can say, proved in 11.3, question 11.3. We know that, but that, where do you take it? Refer the marker there. And we also know from the very first question that we answered that T3, okay, is actually A. Okay, there it is there in what I've written, that we know that T3 is actually A. Okay, and if maybe you want to convince them more, you can state it again that these are corresponding angles also, and well, the same, we're referring to the same line AC parallel to TE. Okay, now let's check what's going on here. T2 is C1, but this thing is that, and this thing is that. So we can see, actually, we can conclude that C1 is A. So if I put C1 here, I get the fact that C1 is T3. So again, if I put C1 here, that's how I get to the conclusion. So since C1 is A, then, and I can write hence since they used hence, okay, I'm kidding. So hence AT is equal to TC. But TC, we know that it is equal to TB. Thus, T is the center of circle. I can call it ABC because it passes through the point A, B, C. So that's about it, guys. This is, yeah, the beauty of geometry. Use what you are given. Once you have proved some stuff, you can also use them. I think that's one key lesson from this question. So don't be afraid to trust yourself and to actually use what you have proven. Till next time, I'll see you guys later.